Okay, we're gonna pick it up from right here. What I had told you last time at the very end was when it comes to expanding and condensing, make sure you just pick the one that you find the easiest. Work that part first. What they told me in class is they prefer to condense. So let's go down here and condense first. Um, Now, if there's a number out front, that is an exponent. So make sure it goes up. So this is ln of 3 squared plus ln 5. Well, remember what the plus sign means. That means that you're adding, because this is your exponent rules. So we have ln, and 3 squared is the same thing as 9. So addition means we're going to go to multiplication. I don't know if I said that right earlier or not, but I meant you got addition here, it turns into multiplication. And you just got ln of 45, and you can leave it just like that. That's condensed. All right, when we come over here, there's a 5 out front. So he's going to be a power. This is 3 times, so that goes to be a power. 6 times, so he goes to be a power. So I'm going to rewrite all these, but let's go straight to the answer. You're going to write log base 5 one time. That takes care of all of these. So don't write it again. All you need now is the little extra parts. So we need the x with its power. So x to the 5th. He was positive, so he's going to be in the top. See, this is positive, so he's going to be in the top. That's y to the 3rd. This one has a negative. That puts him in the bottom. So z to the 6th is down at the bottom. All right, when we come to this one, we're using ln. So we're going to put one ln out front. Now let's look. We have this group, and it's positive. So that's x plus 2 in the top. We have a minus sign, which means you've got to have a fraction because the second part's going in the bottom. But this 3 becomes a power. So I have x minus 1 grouped up with a power of 3. So x minus 1 quantity to the 3rd. Okay, so now let's go back and expand using the same thing. So when you see multiplication, you're going to pull it apart and make it addition. When you see division, you're going to pull it apart and make it subtraction. Okay, but your log, whatever the log is out front, whether it's ln, basic log, or log base 6, that has to be repeated like these original problems were right here. See how the original had the log being repeated? So same thing here. We have 3 pieces, three factors. So when we pull it apart, we got log base 6 of 3 plus log base 6 of x plus log base 6 of y. And that one's done. All right, so when we get to the next guy, log of y minus log of 5. And then we're going to come over here, and again, if it's multiplied, you're going to put addition. If it's divided, you're going to put subtraction. So basically, if it's in the top, it's positive. If it's in the bottom, it's negative. So ln x plus ln y minus ln z. And you're done with expanding and condensing. Okay. Next thing, finally get to the back sheet. And this is where we're going to use all the equations. Now, I did put a note up here. You're going to use a variety of methods. So don't think that you're going to do the same thing to every problem. You're not. If you do, we're in trouble. These are the basic ones. These first 3 are pretty easy. So I would always try at the very first to try to make the bases the same. So if you can make the bases the same, then you can set the exponents equal to each other and solve it out. So over here, can you make 25 as 5 to some power? Well, yes, you can. 25 is 5 squared. Now my bases are the same, so I can set my exponents equal. That gives me x all by itself. I'm done. Okay, on number 2, I cannot write 27 as 9 to some power, but I can take both of these numbers, both 9 and 27, and rewrite them as 3 to some power. So I'm going to do 3 squared for 9. Don't forget your x. And then 27 becomes 3 to the 3rd. So that is 3 to the 2x equals 3 to the 3rd. Now my bases are the same, so my powers must be equal. And I just solve it out and get x by itself. I'm done. Over here, yes, I can write 8 as 2 to some power. 8 is 2 to the 3rd. So now my bases are the same. Drop them. X minus 1 equals 3. Move that 1 over. We got x equals 4. So we're done with those. Moving right along. Okay, obviously we're going to have a different approach. So now we got logarithms. Now remember, your weapon here against logarithms is you want to use either, there's two things you can do. You can change forms, or you can use the same base. So I'll show both forms. Okay, here's the first one. Change forms. Oops, we can't see that, can we? Okay. Change forms. You do not have to do both. I just want you to do whichever one you like best. So if I changed forms like I did previously in the review sheet, I'd have 5 to the third equals x. 5 to the third is 125. Okay, here's the other idea. Or you can go in here, let's rewrite. This means I'm going to use my base to work things out. So my base is 5, right? So I'm going to put down here that base, and basically your problem kind of becomes your exponent. Since these match, they cancel. The x drops down, and you got 5 to the third again. Surprise, surprise. So x is 125. It's just a matter of how does your brain want to approach this problem. It comes out the same way. You just pick which version you like. Okay, when we get to the next one here, totally different. It's an exponential because our variable is an exponent. You're trying to isolate the x. Don't lose sight of your goal. So the 2's got to go. Since it's multiplied, you divide. So we have e to the x equals, what's that, 35? Okay, now, how to get rid of e? Well, e's arch nemesis, his inverse is ln. So you're going to squish in here a little ln. Because remember, ln is log base e. So we're using that same idea where the base here is the same as that. So those cancel, and I get x. And you can just leave it ln of 35. If you want to turn it into decimal, you can. But ln 35 is the exact answer. It contains all the lovely little decimals. And the decimal approximation is just that, an approximation. So just say this one's better. So not by much, but it's better because it's all inclusive. Okay, now number 6 is going to work just like number 4. It's your option. You can change forms, or you can use the base approach. So I'm going to do the base thing because that seems to be pretty common. So since I have a base of 3, I'm going to put a 3 down here. So these two cancel, and I get 4x equals 3 to the 6. I do not know what 3 to the 6 is. So 3 to the 6 is 729. So I just need to come in here and divide both sides by 4. And that doesn't reduce. So you can just leave it just like that. You're good to go. All right, next one's on number 7. Now that's a little different. So you may have to practice on this one. You see how the base is 4, but it is an exponential equation. I've got to get rid of this base. The only way to get rid of this base is I've got to come in on both sides and do log base 4. Now, my problem's a little too tight for me to show that, but this is what I'm going to do. I'm going to do log base 4 and on that side, and then I'm going to do log base 4 on this side. The original problem was 4 to the 5x, and then we got 2,000 over here. So does that make sense what I'm doing? Hope so. When this and this match, these cancel. And so the 5x comes down, and then I got log of 2,000 base 4. Okay, your calculator doesn't do that. You remember earlier what we did? Good old change of base. Okay, change of base rule says log of 2,000 over log of 4. Remember your base goes in the basement. We just need to type that in and get a decimal. So let's just see. Log 2,000, enter, divided by log 4, enter. I came up with 5.4829 once I rounded. Okay, that's equal to 5x. Please don't stop there. I need to know what x is. So you got to come in here and divide through by 5. So keep all your decimals in your calculator, just hit divide by 5. And I'm going to get 1.097 once I round. Okay. Oops, excuse me. I'm not supposed to round there, am I? Shame on me. Okay, let's try this again. 1.0966. There we go. So you can just approximate that one because that just gets kind of nasty right in here. So you just need to go ahead and go to the decimal. All right, for number 8, it actually works fairly easily. To get rid of ln, remember his arch nemesis is e, that's his inverse. Now, when you write that, what I noticed when we did group work is some of you guys did this. You put the e over here. That doesn't help you any, because that doesn't make any sense whatsoever, because you don't see the relationship between the two, the -2 and the e. Write it where here at the very beginning, so this part appears to be the exponent of that e. That's what you need to see. That's what your brain needs. So these two cancel, and I get x, and this literally is e to the -2. I will accept that answer. I would be totally thrilled if you knew that the negative made it go to the bottom, and we've got 1 over e squared. If you feel compelled to type it in and give me a decimal, I'll take it. But these include all the decimals. So whichever one you want to give me, yes, this one will make me smile. Okay. So on number 9, again, your aim is at x. So the first thing you've got to peel off is the 3. Now there is a couple of different ways to work this problem. The easiest way for me is to just divide both sides by 3. And then you can do ln of x equals 8/3. Well, again, you got to get rid of ln. Well, pull out your e. But remember, we're going to write it down here so that the problem appears to be in the exponent position. So that cancels. I have x equals e to the 8/3. You can leave it there. Remember, that includes all the lovely little decimals. All right, for number 10, I do have a typo. So please note that this right here should have been ln of 2. And that'll make a drastic difference in the problem. So sorry about that. I left off the ln. Okay, when you look over here and you see ln twice on one side, you must condense first. Okay, so when you condense this, we got ln, and that's a plus sign, so I need to multiply. X times x is x squared, x times 1 is x. All right, so now again, I got to get rid of ln, so I'm going to pull out the e. When I do that, that's going to cancel here, and I get x squared plus x. Well, look at there. It cancels on the other side. Okay, now hopefully your brain is going, oh my, I have a square. So I'm hoping what that does, it sets off a chain reaction in your brain, and you think, factor. But before you can factor, what do you have to have it equal to? Hopefully you said 0. So that means 2 has to take a hike. All right, now we can factor it out. 2 numbers that multiply to 2 and subtract to 1 would be 2, and 1 signs are different. Big one's plus. So whenever you actually work them out, this is x equals -2, and this is x equals 1. Now, what we had spoken of earlier, if your problem is a logarithmic equation, which means at the very original problem, not what happened in the middle of the problem, but at the original problem, if it had logarithms in it, that means that you cannot have a negative answer. So if anything negative comes up, you just put an x on top of it, don't erase it. I need to see what that is. Your only answer is x plus 1. And just leave it like that. So we're going to have a short video for the next two because I'm all out of time.